Everyone, welcome to my channel Fundamentals. Today we are going to see about 12th standard physics. 12th standard physics, chapter 2, current electricity. A small introduction to current electricity. So current electricity, when I say, it was discovered by Alessandro Volta. He discovered what is called the electric battery in the year 1800. So how did he discover it? His friend Galvani had already discovered animal current. He used a frog, and between the two legs of the frog he realized that a potential could develop, resulting in electric flow of current from one leg of the frog to the other. So based on this assumption, Volta also discovered that two conductors, when there is a potential difference between the two conductors, current was able to flow. Based on this concept, he developed the first electric battery, which is the foundation for steady flow of current. And today's world depends heavily on electricity, heavily on this battery's development in order to survive. So when I say that current, when I talk about current, there is one thing that will play a huge role in current, that is charge. So charges, we already saw in the last topic in unit 1, charges are contributed by electrons. In this picture, if you see, there is a nucleus at the center. This nucleus is positively charged, isn't it? We all know that this nucleus is positively charged. Surrounding that nucleus, there are a lot of electrons in motion. All the red balls represent the electrons. At the last shell, that is at this blue shell, there are a couple of electrons in motion. So the last shell of a atom is called the valence shell, and that valence shell will have electrons known as valence electrons. These valence electrons, I can also call these electrons as free electrons. So these free electrons will never be in a fixed position. They will always be in continuous movement from one place to another. We already saw that charges are always moving within the materials, isn't it? Similarly, here the electrons which contribute the charges will always be in continuous random motion and will never be stable. So it is essential that we analyze the movement of these charges. So this free electrons that are moving around the atom, when it is given a battery or a potential difference, what it will do? It will result in what's called the current, an electric current. So when these free electrons are triggered by a battery or a potential difference which is applied by this battery, it will trigger the flow of current. So now we know that flow of current contributes towards the flow, the electric current, the electricity. So in general, when I say flow, it should flow from one place to another. So from which place is it flowing to which place? Say there is a waterfalls. In that waterfalls, water will flow from a higher gravitational level to a lower gravitational level based on gravitational effect, isn't it? Similarly, when I take atoms, there are two levels. One is the higher potential or the lower potential. So in our case, I am going to label it as higher electric potential and lower electric potential. So in the high electric potential, positive charge is present. In the lower electric potential, negative charge is present. We all know that mass flows from higher gravitational potential to lower gravitational potential. Similarly, positive charges will always flow from higher electric potential to lower electric potential. Likewise, negative charges will always flow from lower electric potential to higher electric potential. So this movement of positive charges towards lower electric potential and negative charges towards higher electric potential will contribute a potential difference. So, because of this potential difference that is caused by the flow of charges, positive as well as negative, from one potential to the other, current is produced. So, we saw that flow of charges will have a huge impact on current. So, how is this flow of charge? How will this flow of charge affect a body? Consider a stream, okay, a river. Consider another river. If you notice, this river has a wider cross-sectional area. This river has a smaller cross-sectional area. Say a man is present here. Okay. So, this man is exposed to water. Water is flowing through this particular tunnel. Okay. Similarly, water also is flowing through this particular tunnel. So, this man, which man will be exposed to more amount of water? This man, because the cross-sectional area is wider, so there will be more flow of water, and likewise here there will be a lesser amount of flow of water since the cross-sectional area is small. So, this is generally when both the water are flowing at the same rate. What if here the water is flowing such that it is a bit slow? Okay. What if there is a slow flow of water here, and here the rate at which the water flows is very high. So, the speed at which the water is flowing is very high. In that case, who will be exposed to more amount of water? This man. Because here since the water flow is reduced, the intensity of water will decrease. Whereas here, since the water flow has increased, the intensity of water will also increase. So, the area in which a person is located will have an impact on the flow of electricity. So, to sum up, okay, we have seen that flow of charge as well as the cross-sectional area will affect our electric current. So, to sum up, we can say that electric current, we can define it such that the electric current in a conductor is defined as the two criteria that we saw. First is rate of flow of charges. The second one is through a given cross-sectional area. If you look at the diagram, here all the positrons are moving in a particular cross-sectional area A, okay, and the current is flowing from left to right. Okay. So, I will repeat, the electric current in a conductor is defined as the rate of flow of charges through a given cross-sectional area. So, this is what we are going to see throughout the entire chapter. In the entire second unit, we are going to see how this current is flowing, how it will be affected. So, how is current measured? We saw electric current flows because of electrons. So, how are we going to measure current? In what units will we measure current? Current will be measured in terms of amperes. Okay. So, I know that current is nothing but charge flowing. So, what is charge? Q flowing through a particular area for a particular period of time, that is T. If there is one charge flowing in one time, then well and good, I can write Q by T. But there is a huge amount of charge flowing in at varying period of time. So, I can say that delta means change in the flow of charge with respect to change in the time. Okay. So, if a net charge Q, the net charge Q passes through a cross-sectional area of a conductor in a time t, then that can be defined as current. However, since it is not constant, we can say that change in the charge with respect to change in the time will contribute our current, and it is measured in terms of amperes. So, I will further define I is equal to, we know it is Q by T. So, 1 ampere of current is nothing but 1 coulomb. What is the measure of charge? Coulomb. So, 1 coulomb of charge passing through a perpendicular cross-sectional area, within a period of 1 second. Okay. So, an ampere is nothing but coulomb per second. This is the electric current basic definition. Okay. So, we saw what an electric current is. In this chapter, what else will we be seeing? So, in this introductory class, I will just skim you through what and all the topics that you will be seeing in this particular chapter. So, in current electricity, you have electric current, Ohm's law, energy and power, electric cells and battery, Kirchhoff's law, heating effect of electric current, and thermoelectric effect. So, electric current, we will be seeing about conventional current, that is the direction in which a positive test charge will be moving. Similarly, we will also be seeing about drift velocity, the average velocity that an electron acquires inside a conductor and begins to move. Based on that, a small microscopic model will be developed. This microscopic model will be used to find out what is current in terms of area and drift velocity. Similarly, we will also find current density J. Next, we will be seeing about Ohm's law. In Ohm's law, in particular, we will be seeing how resistance can be measured, and then the definition of resistivity. We will also be seeing about how the resistance are in series and how they are in parallel. When they are in series, how will we find the current? When they are in parallel, how we will find the current? A basic resistor is shown, and the color code for the carbon resistor is here. The first 3 bands will indicate the value of the resistor. The last band will represent the tolerance of the band. Next, we will see how temperature increases as resistivity of the particular material increases. We will also see about energy and power. When a battery is connected between 2 conductors, current is established. So, that current or that battery will transport energy, and how it will account for power. We will see about electric cell. What is an electric cell? It converts chemical energy into electrical energy to produce electricity. So, many of these electric cells, when they are placed together, they will develop into a battery. So, how this battery will be used as the source of electromotive force, and the internal resistance, how the internal resistance of that particular battery should be. We will also see how the cells can be placed in series and parallel. We will be seeing Kirchhoff's law. There are 2 Kirchhoff's law, law 1 and law 2. Law 1 is the current law, law 2 is the voltage law. We will be seeing Wheatstone's bridge. So, in Wheatstone's bridge, we can find out the resistance that is missing. We can find the resistance. Say there are 4 resistance, we will be able to find out the resistance of the unknown resistance value. Similarly, we can also use meter bridge. Here, Wheatstone bridge and meter bridge both are used to find the unknown resistance, with the difference that meter bridge will be using the meter scale. Potentiometer. Potentiometer is used to accurately measure the potential difference, current as well as resistance. How we will be doing that? Next, we will see heating effect of electric current. That is, when current is flowing through a resistor, some energy will be liberated in terms of heat. So, that loss of heat energy, how that is brought about, we will be seeing that in Joule's law and its application. Finally, we will be seeing thermoelectric effect. That is, because of difference in temperature, it will result in electrical voltage, and when that results, there are three effects: Seebeck effect, Peltier effect, as well as Thomson effect. So this is a complete summary of your second chapter. In the next video, you will be seeing a part of your second chapter. Do join me in. If you like this video, please do like, subscribe and click on the bell button for more updates. Thank you for watching.